Welcome back to the YouTube channel. This is day 3 of the series of LeetCode every day until I land a new job. Today we're going to do another easy problem, but we're going to stay on the topic of linked lists. This one's LeetCode number 141, linked list cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that tail's next pointer is connected to. Note that position is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise false. And then let's go ahead and look at our constraints. Okay. So basically, I already read the problem and just drew this ahead of time. So basically what we're looking for is there a cycle in the linked list? So we want to know, the head points somewhere, points to the next node. The next node points to the next node, Does this go all the way until something points to null? So is there a tail that points to null? Or does that not exist? Is there in fact a loop? Does this point back here, back here, back here somewhere? So this is a great problem because it utilizes something that we call I think it's called like the fast and slow, or I've heard it called the tortoise and the hare. But basically what we're going to want to do is we're going to have we're going to create a node, and we'll call it fast, and then we'll create another node and we'll call it slow, and they'll both start here. But what we're going to do is we're going to have fast move through the linked list faster than slow does. So we're going to have fast go to next, and slow will just go to next. And what this will do is we'll then compare if they equal each other. And we'll also check to see if fast gets to null. Because if fast gets to null, then we know there's no loop because we have a tail that points to null. So fast and slow don't equal each other. Well, we're going to have fast go to next, which in this circumstance would bring it right back to this node, and slow will go on, and then we'll say, do slow and fast equal each other? Well, they do. We have a loop. We've found a loop, and it doesn't matter where in the linked list this loop is. The loop could be all the way back here, and we wouldn't have fast be at 3 right now. It would have gone to next, and then we increment slow, and we'll increment fast again to next, and we'll increment slow, and we'll go to next. And point being, it doesn't matter where the loop is. By having one iterate through twice as fast as the slow, we will either get out of the linked list or we will find each other. These two, the fast and the slow, will be the same. And this is really useful to know, the fast and slow method, because there's a lot of problems where this will pop up, and so this is one that I'd kind of recommend almost having memorized to a degree. And this will run in a linear time, so it's a pretty good solution. So basically what we're going to do is we're going to have we're going to have a list node, and we'll just go slow, and it'll start at the head, and we'll have a list node fast, which will also start at the head, and then we're going to say while fast is not equal to null, and fast.next is not equal to null. And then all we're going to do is we're going to have slow equal slow.next, and we're going to have equal fast dot next dot next, and then at the end we're going to say if slow equals fast, return true. And if we make it all the way through this, we'll return false. And go ahead and run it. Pass our test cases, hit submit. And like I said, this will run in linear, and the space is O of 1 as well. Or, well, not O of 1 as well, just O of 1. Which is actually, if we go back to here, we can see follow-up. Can you solve it in constant memory? Which we did, because we're just creating these two nodes. We're not, creating more space for each node as we loop through, which I guess would be one way to approach it, but this is faster and better in memory. So once again, thanks for joining in this series where I'll be doing some LeetCode problems every day until I land a job. Like I said before, if you have any recommendations for the channel, anything, please leave them in the comments, and please like, and we'll keep doing this until we get a job. So have a good one, everybody. Thank you very much.